So in this video I'll be discussing about the concept of stack data structure. Actually it's also it's like linked list data structure, which is also a conceptual data structure, that is ADT, and stack is also a conceptual data structure. So it doesn't exist by itself. Well, in some programming language it does, like in C++. It has an inbuilt library of stack, but we usually build it from different data structures, like from array, or we can build it from linked list also, and many other ways. So today I'll be discussing about the concept of a stack, so that it will be clear to you. So stack is, in general, life is very similar to the programming life. So in general, a stack is anything with a linear structure, one over another. Like you have seen a stack of books, in which one book is over another book and over another book and so on, creating kind of a tower-like structure. One book, then another, then another, then another. Similarly, you have seen the structure of plates arrangements. Whenever you arrange plates in a fashion that one plate is at the bottom and other plates which we are placing are on top of it, the next third plate top of that second plate, and in this way you create a structure. That type of structure is typically a stack structure, and the same way we use that in data structures as in computer programming concepts. So let's just start it. So think of a stack as, not think, but actually that's the main reason why we use stack in such a way. Okay, so here you can see this big blue box, big rectangle. So imagine it to be a memory space in a computer. So, and these are some colorful bricks we need to put in that memory. Actually, suppose it's some data we have to put in the memory. So how a stack will work? So first of all, we have to add an element, and for that what we'll do, famous operation of stack, which is push. Not that push bar, it's push. Okay, so what is it? It's simply adding elements to the stack. So what we'll do, simply nothing, we just grab this yellow data piece and throw that into the stack, into our memory. So this is what we call push. And you see how we did it? Actually you will not see. Let me throw another one. Yeah, so you see the first one is at the bottom and the next one is at the top. So now whenever I'll push any other data, it will again go onto the top of the screen. Now in the same way we can add these remaining data bricks. Now you can see that our box is full, so our stack is full. So currently if we try to add another element, we'll face a problem, and that problem is generally known as the overflow problem. What does that mean is, you can see that this box is approximately to the size of these 4 data bricks. Means if we try to add another brick, it will fall out of it if we suppose it as a real life box. So what you can do, so you should have taken initially a larger box to fit in larger number of bricks, but as you have taken a size of 5 only, so you can only insert, or in stack language, push only 5 data elements to it. So if you try to access and try to push more than that, you will face an overflow error, which is pretty intuitive. Overflow means over the flow. it has been full. Okay, now the another operation that we encounter with the push is its reverse, that is pop, that is removing the elements from the stack, and how it is done in the same fashion as we done the push operation. We push an element on the top, so we remove an element from the top. So you see the blue brick, so we'll remove it first, then remove the green brick, and the stack is empty. And if you now want to remove any data point, any data element from the stack, you can't because it's empty. So here you will encounter with another error if you're trying to remove any element from an empty stack, that is underflow. Means it's already empty. What are you taking to out of it? It's nothing there. Okay, now let's discuss about the basic major operations. Actually, we have seen them. Those are push, pop, and peek. So we have already seen push. Push is adding an element onto the top of the stack. We only can add an element on the top of the stack from the top. Other one is pop. So pop is also same, removing an element, and that is too from the top. So we just simply doing the same thing, removing from the top, adding from the top. So it's a linear structure. So when this pink brick will removed, only after that then the red can be removed, and after that the blue, the green, and so on. And the third one is actually pretty useless but very useful. It's peek. Peek means it will return the value which is at the top. So in this case it will return the pink value. If pink was removed, then it will return the red value. So simply whatsoever is left on the top of the stack. So generally a stack works in the fashion of LIFO, that is last in first out. You see, at first we pushed the yellow brick, then green, then blue, then red, and at last pink. But while we are removing it, the pink one is removing by first. So LIFO is last in first out. So this is a basic terminology of stacks, and this is the very basics of stacks, and actually this is all what you need to learn about the concept of stack. So I hope you learned something and enjoyed the video. So see you in the next video.